So, Vanakkam. So, we will continue our lecture on engineering seismology. So, we have been discussing about the prediction of the earthquake. So, we have seen that the earthquake can be effectively predict. So, if you observe some of the precautions, what are the precautions we have discussed? Basically, we discussed the unusual animal behavior, which is very success in predicting Chinese 1975 earthquake of magnitude 7.3. So, apart from that, so the Chinese people also related the other unusual other behavior such as a rise in the water level, hydrochemical process, okay, rise in oil wells, okay, rise in the temperature in the region, okay, chemical concentration in the water. So, all those phenomena they clubbed together along with the foreshock, they effectively predicted magnitude of 7.3 before 6 hours, where they could save life of millions of people. Okay, that was one of the very best classical example of the earthquake prediction success. Okay. So, which we have seen that all this prediction, okay, the animal behavior as well as the well level variation, temperature, all linked with the crust. So, if you have the crust, earth crust projected to the ground, the wells are drilled in those earth crust, okay, because this deformation will be well represented in the rise in the water level as well as rise in the water oil level, and also the temperature variation, because the crust is going to twist, okay, because of that there is a change in the pressure and temperature of the crust material which reflect in the region, okay, which has been sensed by the animal as well as the instrumented wells and as well as the data recording in that region. So, which is very classical example that when there is a crust close to the surface, you can very well predict these parameters accurately, thereby you can also predict a earthquake in that region. That period depends upon the different observation. We have seen that there are about 2-3 hours early to the 72 hours early people are observed on different phenomena. So, this is basically wells works well when the crust rock projected to the basically in the region. But in case, okay, the crust rock below some level, so that is some of the places, like if you want to see the rock level at Indo-Gangetic basin, so particularly the Uttar Pradesh. So, if you want to see, you have to go at least 100 meter to 4 kilometer, 6 kilometer below the surface. So, those kind of region, even this kind of things are maybe very difficult. Okay. So, that we have to keep it in mind. So, the similar way of other this one, there is a data based earthquake prediction which is explained in the coming few prediction methods. One of them is basically theory of seismic gap. Okay. So, what is mean by seismic gap? The seismic gap is a region where the earthquake activity is less compared to its neighborhood along the plate boundaries. So, this seismic gap basically concept which is applicable in the close to the plate boundary. The Soviet seismologist AIS Fedorov studied a seismic record of 12 large earthquakes which rocked northern Japan between 1904 to 1963. By plotting the size of each tremors struck area, he found that each quake segment abated the next contiguous one with overlapping. So, this deep seated crack have been shoved up the barrier of end of the fracture zone. So, each large earthquake was segmented, that was quite for a large 39 years, at least last for 39 years. Fedorov predicted those segments which were quite for some time will be hit the earthquake sooner or later. 3 these blocks are Kurili Island were stuck where according to the Fedorov an earthquake was due. So, thus endured the theory of seismic gap in the earthquake prediction. So, what it means basically, the seismic gap means, so basically the seismic gap, okay, so this is the basically a plate section, you assume this is the plate section, okay, this segment ruptured, okay. So, this segment ruptured, so this is the segment which is not ruptured, this segment, so this segment ruptured, so this segment ruptured, so this is the segment not ruptured, again this segment ruptured. So, this is the ruptured, 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 ruptured. So, this is the area where there is no rupturing. So, this is called as a seismic gap. This is called as a seismic gap. Since this, you know that what is the M and happened, this is the M happened, M happened, M happened. This place there is no M is happened. So, that means this area potential for the future big earthquake similar to this range. So, that phenomena is called as a seismic gap. So, where people can say that this big earthquake can be expected on this area. Okay. So, such kind of statement can be made from the seismic gap kind of theory. Okay. So, the seismic gap concept has been extended. Okay. So, based on this theory, Dr. Kyo Mogi of Tokyo succeed in predicting a few earthquakes in Japan. 3 geophysicists Masakosu Hotak and then Toshimatu Motomo and Grave Latham working at Texas University Marine Science Institute had predicted a major earthquake in southern Mexico around the town of Puerto Angel based on the theory of seismic gap. So, this theory has been used and many people predict the earthquake. On November 29th, okay, so on 29th November 1978, severe earthquake measuring 7.9 at Richter scale with epicenter with kilometers of the predicted site struck a area. A seismic gap predicted quake also occurred along the San Andreas fault. So, this is where the predictions are basically success. So, you should have the complete knowledge of the segment earthquake produced in the particular region, then you could be able to predict a earthquake there. So, that was one of the beauty. This seismic gap not only exists in those areas, this seismic gap also exists in India. So, in India 3 seismic gaps have been identified, one in Himachal Pradesh which is lies along the plate boundary between earthquakes of Kangra, okay, 1905 to the Kennu 1975. The second called Central Seismic Gap between 1905 to 1935 earthquake. Third called Assam Gap in the northeast India between the earthquake of 1899 to 1850. Identification of this seismic gap can go a long way predicting the earthquake in this region. So, that is why many seismologists, okay, so the BILM is actually origin of predicting seismic gaps in Himalayan region. Many seismologists believe who follow a BILM literature and all, including I also accept a BILM theory on seismic gap at Himalayan region. So, there may be a big earthquake due at a plate boundary at Himalaya, northern Himalaya particularly. If this earthquake occurs, there will be a huge infrastructure failure and many people will die in the northern part of India. But I do not know when it occurs, as the sequence of the earthquake occurred in Himalayan plate boundary is not well defined. Okay, we have only few earthquakes, not all. So, because of that, the time prediction of the future earthquake is problem, but it is believed that there is a seismic gap in Himalayan belt. It is theoretically and experimentally also people believed that there is a seismic gap in Himalayan belt. That gap releases a energy that may cause a magnitude of 8 and above. Okay, so 8 and above can be expected, which will affect basically the entire Indo-Gangetic basin and Nepal. So, even a 2015 Nepal earthquake believed to be a not part of the seismic gap, but it is a the interaction or initiation of the seismic gap in the region. That is what some people are believe. So, there is a paper related to this. Those who want to study about the Himalayan earthquake work on this region. So, it is always advised to consider this for the particularly very important projects like a nuclear power plant, dam construction. Okay, so, the multi level hazard required for the infrastructure development need to consider this as a probable future earthquake location in the Himalayan region for the design purpose. Okay. So, this is the seismic gap theory on earthquake prediction. So, the next one is actually the foreshocks. Okay, the foreshocks, as we have seen that the foreshocks are the earthquake which is occurring before a main earth shock. Okay. Generally, the major earthquakes are preceded by the minor shocks as we called as a foreshocks. These foreshocks provide valuable dues to the occurrence of the strong earthquake. Some of the earthquakes have been successfully predicted on basis of the study of foreshock. In addition to unusual behavior of animal, okay, so Aiching in China earthquake was the classical example where the foreshock and unusual behavior are clubbed together. Then the Oaxaca, Mexico earthquake November 78 was also successfully predicted based on the foreshock observation. Okay, so these are all the classical example where other precautions are linked with the foreshock and then the earthquakes are predicted. The foreshocks have been detected even in India. So the foreshocks have been detected at a few days to a month in advance with help of closely located seismic station at Himachal Pradesh. Several earthquakes like Anantnag, Dharmashala, Kashmir and the Kannur and few others. But these are all data are reported. Okay, people said that this is the foreshock but this main shock, not warning system issued. So the Uttarakasi earthquake of October 20th, okay, 1990 was preceded by the foreshock of October 15th, 16th magnitude larger than 3.5 Richter scale. The most recent Bhuj earthquake of January was also preceded by the foreshock of December 2000. Okay, but these are all some other earthquakes which were preceded by the foreshock. Therefore, it is not flawless method to supplement by the other method of earthquake. So the foreshocks is unrelated with the animal behavior. One can say that the earthquake predictions are more or less accurately possible. But there is a risk here. Some location the foreshocks are few days before, some location the foreshocks are few months before, some location the foreshocks are few years before. As we have discussed in the some of the classes in the previous, I told you that there is a foreshocks being frequently reported in the NCR region of Delhi. Okay. So this NCR region the foreshocks are reported. If there is a unusual animal behavior on the same area, epicentral area, there may be a big earthquake within the 24 hours. So if somebody monitors that, there will be definitely say, okay, that could be used, but the people should work in that region should aware both of them. Okay, like there is a foreshock, this epicenter region, people also should monitor the burrow animal, particularly snake, rat kind of behavior in that. So then if they see that unusual behavior, they could easily predict a bigger earthquake, it going to happen in that region whenever. Okay, so that is a phenomena. The foreshocks are more helpful for the forecasting the earthquake. So the another phenomena scientists also observed that changes in the seismic wave velocity. So as we know that P, S and L waves are originate from the earthquake focus and propagates and reaches to a particular site based on the site where the site and epicenter is located. As we know that P wave comes first and S wave next and S L wave then later Rayleigh wave. So this is the sequence of the wave which we have seen by studying a theory of wave propagation, wave character and all. So the time lag between the arrival of P and S wave is called as a lead time. That is called as a lead time. The Russian seismologist found that the lead time begin to decrease, okay, significantly for a days and weeks and even a month before a earthquake. So the lead time, for example, the P wave and arrival, there is a ratio you can get constant for a particular region. This value goes below that constant value, okay, then there may be a big earthquake going to occur. Okay, so before a quake, the area lead time was back to normal. So there is a decrease and again back to the normal. The longer period abundantly in the wave velocity presaged a larger quake in the region. So if somebody monitor this lead time effectively, one can predict basically earthquake in that location. So taking a cue from the Russian and then the Lee Skykes and Skal and Agarwal conducted laboratory, okay, so experiment and rock samples in 1973. So this experiment showed that abnormal change of ratio of the P and S wave velocity before the earthquake. So if these observations are made very accurately, okay, so the ratio of Vp and Vs, the duration of Vp and Vs anomaly depends upon the fault and dimension of the aftershock area. After Garm region of the former USSR, VP versus VS anomalies were noticed Blue Mountain Lake earthquake in US in 1973. The velocity anomaly period of this earthquake was about 5 days. Okay, so decrease the velocity was about 12%. So this lead time decrease, okay, for the before earthquake we very accurately noticed and reported. Okay, so that will help you to predict a earthquake in the region. Similar decrease in the velocity ratio also reported by the damage Aiching earthquake and then the other earthquakes in China and Japan, even 4 to 40% decrease in the velocity ratio 50 to 700 days before earthquake. You can see the number of days. So the main earthquake were recorded in Tehran, 40% decrease in the velocity was reported, 1 to 3 days earthquake in 1974. So the lead time variation and decrease somebody observes, that will help to predict a earthquake in the region. Okay. So the immediately after the Gujarat earthquake of 2001, the Survey of India mooted a network of 300 permanent GPS station all over the country to monitor the earth movement round the clock, which help to predicting the earthquakes. So if the GPS system are located along the known active fault, it is possible to monitor the movement of the active fault break in the earth crust, though no precise prediction can be made about the location of the and magnitude of earthquake. Minor movement are in the indication of the implementing the seismic earthquake, impending the earthquake because of the reflection of the force coming to the floor. So basically after Bhuj earthquake, so the Survey of India deployed the global geographical positioning system throughout the country and tried to monitor the movement of the plates, okay, the fault or rock. So as we know that we studied that if there is a movement at a particular place, movement happening at a particular place, that movement indicates a seismic activity. The seismic activity indicates that there is a earthquake going to occur. But again, the when and how much is the question. So that is also has to be addressed part of the prediction, but the change in the velocity overall observed in the earthquake region before a big earthquake. That was a message which we can get from this one. So if you look at this theory, whatever we are discussing, the 9 approach to predict the earthquake. So it's very clear that there are many method is basically related to the mechanics and the theory of the plate tectonics, okay, or the elastic rebound theory. Okay, so the elastic rebound theory, its behavior in the region will help to identify and predict a earthquake at a particular location. So which is well established and well understandable. Okay, so where the earthquake can be predicted in the plate tectonics concept. So if the crust are very close, if you monitor some of the crustal deformation, like if you have the seismic instrument and it record a waveform, so the force shock, okay, the VP and VS ratio, okay, so those are all the recorded information will help you to identify the unusual earth signaling. You can say it is earth signaling, which will help you to identify a big earthquake due in that region. Okay, that is one of the classical way we can look at it. So apart from that, the well and the oil well and then the water well linked or drilled in the crust where it is going to break, there is a unusual rise in the temperature, level of water, level of oil, and then the water composition. As we have seen that the breakage, okay, basically try to release the minerals in the area, or the minerals undergo a change or conversion or increase or decrease the concentration before breakage. That will seen in the evidence in the wells. Okay, so that concentration hydrochemical process or precursor constant. So these two, if you link with the animal behavior, animal unusual behavior in the region, you can pinpoint epicenter location precisely. Okay, so if not 1 meter, at least by a kilometer you can pinpoint. So as we have seen that the animal behaviors are related with the size of the earthquake magnitude, so we can also predict size with that. Okay, so the other methods actually will tell you only roughly the days. Okay, sometimes it is very short, sometimes it is very long, but overall linking up any of these methods will help you to predict a earthquake as much as close to the actual event. Okay. So, that is the one message. So, what constitutes a valid prediction? Okay. So, the valid prediction basically should be the date and time. Okay. I should say that it going to occur on such a date, such a time. Okay. Then the place, okay, with variation of small level, not 1000 kilometer, 100 kilometer variation, it may be the few meters variation or 1 or 2 kilometer, single digit kilometer variation is accepted. Second, the size of the magnitude, as we have seen that the damage of the earthquake is the function of energy carried by the seismic waves, that is the function of amplitude of the seismic wave, that is the function of magnitude or size of the record. So, the record in written form. So, not only predicting this, if you predict this, basically you should get at least synthetic ground motion data which is possible or expected in the region. Then only people do analysis using this and say that this is the expected damage at this place, this is the expected failure you can get. Okay. Then the probability of confidence of estimation. So, say that 10% confidence, 50% confidence, 90% confidence about this prediction, that also is basically the constitutes a part of valid prediction. Enough of scientific basis for the prediction that is valid can be evolved. Okay. So, basically you can get all these materials from the internet. I also taken for the teaching, as I do not work on the earthquake prediction right now. So, there was a case also, basically I also told that we did not discuss here that method explicitly. So, there are theory of like the planet position for prediction of earthquake. So, as you know that the sea waves controlled by the moon position and the earth position, correct. The similar kind of concept has been extended by the astrophysics, okay, where they position the different time what is the planet position. Then they say that when these planets are coming in a particular alignment, okay, then there is a imbalance created between the attraction between the planets which can cause a earthquake in the earth. Okay. So, that kind of predictions are well known, many people are there, but we did not explicitly discuss that. There is a ambiguity and also that theory itself is a separate topic of research. Okay. So, what I did actually, there was some geologist from Chennai who are working in this kind of area. So, he was suspicious that there may be such kind of coincidence going to happen close to Coimbatore, where there was a 6.3 magnitude reported 1900. Okay. So, then since it is very near to the Bangalore, I also thought that, so let us see what happens. What we did actually, so based on his the input and his interaction with the astrophysics who predict all over world this kind of phenomena. So, then I deployed a seismic station at wherever he said nearby, but it was not happened. Okay. So, we have written even paper and submitted before the earthquake, but fortunately earthquake was not happened. So, unfortunately the time what I spent to writing that paper and doing that analysis has become a waste. So, because of that, so the prediction method which is not having enough scientific basis, okay, cannot be considered as a valid and method for prediction. So, one of them is this planet position, basically what they say, as you know that this is the earth, this is the moon, then there is another planet rotates on. They say that if these are all comes on alignment, so there will be a imbalance force happens. So, this causes a earthquake in the earth. Okay, that is what they say. But one of the cases where it has been predicted, but it was not happened. So, which believed that this is not the good direction I should work. So, even if you predict the science what I work actually needed for save the people. So, prediction of earthquake alone will not save the people. You should know the predicted earthquake, how waves will propagate, how it will affect, what are the failure it causes. Okay. So, that kind of research only I do, not the prediction of earthquake. Okay. So, because of this reason I have most of the materials what I have taken from the internet. Okay. It is not my own material. So, the prediction accuracy can be assessed by the known set of condition described by the this one. So, you can see that the observation and prediction, the S true prediction hit success A. Okay, how much success is the, so the B, false positive, false alarm type 1 error, okay, false negative, miss type 2 error, true negative, correct negative and the correct rejection. So these are all the A, B, C, D, okay, with observation and prediction, yes and no criteria. So you can say the accuracy of prediction and then the false alarm using some kind of mathematical formation. A prediction can be made, okay, or not, an earthquake may occur or may not. These basic possibilities are shown in the contingency table at right side. So one of the various outcome are tabulated, various performance measures can be calculated. The success rate is the portion of all prediction which were successful, okay, SR is equal to A divided by A plus B. Okay, so these conditions are coming, this is the success rate. So while the hit rate, the alarm rate is proportion to all the event which were successfully predicted, A divided by A plus C, this is a hit rate. The false alarm ratio is proportional to the prediction which are false, okay, B divided by A plus B, and this not be confessed with the false alarm rate which is proportional to the B by B plus D. So this is the success rate, hit rate, false alarm and false alarm rate. So this is some kind of quantification people have given with respect to the rate of prediction, success, hit and false rate kind of theories. So which will be useful basically to evaluate how accurately you can predict a earthquake. Okay. So as we have seen that, so last couple of classes, last 3 classes we have been discussing about the earthquake prediction. Okay. So we found that as on today there is no confirmed theory to accurately predict a earthquake. Okay. That means nobody can say that this is the magnitude, this is the place, this is the time it going to occur. That is very clear. Okay. Nobody can predict a earthquake. But however, there are some scientific basis, okay, which as a scientific proof and as the concept related with the plate tectonics and rupture phenomena during the earthquake. So one of them is animal behavior. Okay. So since before the big earthquake going to happen, the earth will undergo a highly strained way. Okay. So it will stressed, highly stressed. That stresses will radiate some kind of chemical as well as some kind of unusual waves which will be sensed by the animals, okay, which is very sensitive animals like a dog, rat, burrow animals like snakes. Okay. So those are all the animal, birds. So these are all sense that their behavior, the unusual behavior of the animal can be observed before within 24 hours of the earthquake. Big earthquake particularly is possible. They observed that it is behave very unusual way close to the earthquake time, 2 to 3 hours before the earthquake it will behave very unusually. Okay. So that is the proof they have seen. Then if you link with that other prediction like the foreshock, okay, foreshock, then the prediction will be having more success rate. Then the hydrochemical precursor, okay, the change in the water chemical concentration at a particular place, okay, then the water level rise, oil level rise, temperature rise and drops. So these are all the behavior, these are all the phenomena one can monitor and then link with the animal behavior where this is possible closely, the crust is close to the ground. Okay, those are the region which is highly possible to predict earthquake using linking up these 2-3. We have seen that the China 1975, okay, 7.6 magnitude predicted by linking these conditions continuously, help of foreshock and then the animal behavior and then the water wells level variation and all. So which can be taken as a very basic relation with the earth crust deformation behavior. So apart from that, if you have the instrumented data at some location, so where you can see the seismic gap, okay, where you can predict a earthquake size in the seismic gap. We have also seen that seismic gap in Himalayan region, which we will be discussing in detail when we are talking about the Indian seismicity, where this is very necessary. Then we also seen that P wave S wave ratio, lead time, okay, the lead time change before the earthquake. So that also we have seen one of the useful parameter. And then the seismic activity by monitoring the movement of the plates. Okay, so you keep monitoring the movement of the plate. So as we have seen that the active pulse where there is a seismic movement is taking place. So these are all the method you need, basically instrumented data, basically waveform data recorder. Then only you can estimate what is the pore shock. You need earthquake history of the region where you can find out a seismic gap. You need the digital recorded data at different places where you can find out VPVS and lead time variation in the several days and month. Then you can compare the unusual variation what you are observing will be counted on this one. So here I can also say that this unusual behavior sometimes get into the wrong prediction because of the some kind of phenomena which happens. As you know that, so now because of the COVID, okay, the lockdown has happened throughout the world at a different period. So this lockdown basically reduced considerably the human activity in the planet. So this human activity in the planet reduction will source very good rise in the seismic recordings of the tide, earth tide. Okay, the earthquake prediction, okay, earthquake wave recording and assessment is becoming more easy because of the lockdown due to the human movement stoppage. Okay, so people of movement are stopped, which helped. So this kind of variations also has to be accounted when you talk about the prediction of lead time. Okay, lead time studies and all, one has to talk about that. So overall you can see that all this prediction, okay, whatever we are talking may not be very accurate as we are expected. It depends upon the solely a data and observation, how you link 2-3 method together. So you might have seen that I don't know how many of you familiar with this COVID background actually. So now the COVID virus has been put on several restriction, people have locked down and all. A year back or 2 years back, there is a group of people, they simulated if this kind of virus are going to come, how the world will behave, which are the industry will affect, how much will affect, how much economical loss will. So then after that it happened. So there are people who believe that there is a linkage between that model studies, okay, that prediction model with the real one. Why? Because many people they raise their share values and sold it, okay, by based on this. Then this COVID has come, many people get affected, the economic loss begin and a lot of things were happen in the financial sector. Those who are interested to see those kind of things, you please Google it and find out. Okay, there is so this kind of modeling, okay, the modeling and prediction, so may be very accurately match with the artificial kind of things, but may not match with the natural scenario. But natural scenario you cannot work with one model. For example, lead time alone may not be sufficient, okay, seismic gap alone may not be sufficient, pore shock alone may not be sufficient. But if you link 4-5 success cases out of 9, then there is a possibility that you can predict very accurately earthquake, but that needs lot of instrumentation and finance support to monitor. If you monitor, that is possible. This is kind of technology is really needed in Himalayan region. As I said that there is a seismic gap. Okay, if somebody monitor all these parameters in those region, which will basically help you to predict a big magnitude and save at least life of the people, if not infrastructures. Okay, so but this prediction, if it is not accurate, it create a socio-economic impact. Okay, that socio-economic impact many times larger than the impact created by the earthquake. For example, the earthquake magnitude of 6, okay, if it happens at some location, only 100 people will die, 500 crores will loss. But if it is predicted in advance wrongly and informed to people, there may be 1000 people will die and 5000 crores loss will be there. So this kind of unusual socio-economic impact of the earthquake predictions are very important. So scientists believe that how the socio-economic impacts are important, why the prediction should not be told just like that without verifying the prediction. So that we will discuss in the next class. So with this we close today class. Thank you very much for watching this video. So we will see you in the next class. Thank you very much.